The Monte Carlo simulation analysis is a technique used to assess uncertainty and risk in complex systems or processes. It employs random sampling and statistical analysis to model possible outcomes and provide insights for decision making. This lecture explores the concept, process, and significance of Monte Carlo simulation analysis. The Monte Carlo simulation analysis derives its name from the famous Monte Carlo casino, known for games of chance and randomness. The technique mimics repeated random sampling to estimate the behavior and outcomes of a system under uncertain conditions. It is widely used in finance, engineering, project management, insurance, and other domains. The significance of Monte Carlo simulation analysis lies in its ability to handle complex systems with numerous variables and uncertainties. It provides a probabilistic framework for decision making, enabling stakeholders to understand the range of possible outcomes and associated risks. The process of Monte Carlo simulation analysis involves several key steps. First, the problem or system is defined, identifying variables and factors contributing to uncertainty. Next, probability distributions are assigned to these variables, representing the range and likelihood of different values. Random samples are then generated from these distributions. Simulations are run for each set of sample values using mathematical models or simulation software to evaluate the behavior and outcomes of the system. The results are analyzed using statistical techniques, such as calculating summary statistics and assessing the level of uncertainty. Finally, the simulation results are interpreted to gain insights into the system's behavior and make informed decisions. Let's briefly touch upon some key benefits of Monte Carlo simulation analysis. Risk assessment. Monte Carlo simulation helps assess and quantify risk associated with a system or process. It considers the interdependencies among variables, providing a comprehensive view of potential outcomes and their probabilities. Decision support. By simulating various scenarios and strategies, Monte Carlo simulation enables evaluation of the impact of different alternatives and supports decision making. It helps optimize resources, identify critical factors, and select the best course of action. Uncertainty analysis. Monte Carlo simulation allows for a detailed analysis of uncertainty. It provides insights into the probability distribution of outcomes, highlighting the likelihood of best case, worst case, and most likely scenarios. This aids in risk mitigation and contingency planning. Sensitivity analysis. Monte Carlo simulation helps identify influential variables or factors in a system. Through sensitivity analysis, decision makers can prioritize their focus on critical variables that have the most significant impact on outcomes. This guides resource allocation and risk management strategies. Confidence analysis. Monte Carlo simulation provides confidence intervals around the simulation results, indicating the level of confidence in the outcomes. This information helps stakeholders understand the range of possible values and make decisions based on the associated uncertainty. Flexibility and adaptability. Monte Carlo simulation accommodates changes and updates in the system by allowing modifications to input variables and probability distributions. It enables decision makers to adapt strategies and plans based on new information or changing circumstances. Despite its benefits, Monte Carlo simulation analysis has limitations. It relies heavily on the accuracy and representativeness of input data and assumptions made for probability distributions. Gathering reliable data and expert opinions can be challenging, especially for complex systems with limited historical information. Additionally, Monte Carlo simulation can be computationally intensive and time consuming, requiring significant computational resources for large scale simulations. Monte Carlo simulation analysis is a valuable technique for assessing uncertainty and risk in complex systems or processes. By employing random sampling and statistical analysis, it provides decision makers with insights into the range of possible outcomes, their probabilities, and associated risks. Monte Carlo simulation enables more informed decision making, facilitates risk assessment, and aids in resource optimization. Despite its limitations, this technique continues to be widely used in various fields, empowering stakeholders to make better decisions in the face of uncertainty. See you in the next lecture.